Good morning, good afternoon, and good evening, ladies and gentlemen. It's my great pleasure to introduce you to the next virtual webinar in the International Society for Respiratory Protection series from the European section. Today's presentation is on confined space, the hidden hazard. And our two keynote speakers for today are Stuart Airy from 3M in the United Kingdom and Laurent Hervé from Sanofi in France. So just a little bit of background on ISRP, the European section, before we get into today's webinar. So I'm the chair of the European section, and the International Society for Respiratory Protection is a non-profit organization whose charter is to provide education and information for anyone involved in respiratory protection. Overall, we have 6 sections. Today, with this, we're representing the European section, but we have Americas, Australasia, Japan, Korea, and the Greater China. And the objectives of the society are to enhance health and safety of anyone involved in respiratory protection, whether that's through the development of society standards and best practices, through research and evaluation of respiratory protection, but also part of today's exercise is the exchange of information amongst fellow respiratory protection operatives, whether that be government, industry, organized labor, or educational organizations, or manufacturers, or even other societies. So that brings us on to today's education program. And the aim of our education program within Europe is to introduce attendees to different areas of airborne hazards, what type of respiratory protection is required, and how we can mitigate those hazards through new technologies and new understanding. So the idea of today's webinar is around confined space, and we have 2 leading experts to discuss the background theory and practice behind confined space operations. So in terms of previous webinars, just to give you a bit of background information, we've held 4 to date, and these can be found on our YouTube channel. Copies of the slides will go out to all attendees afterwards. So I'm not going to talk about them too much today, other than to give you further information. So on to today's topic. So it's my great pleasure to introduce my working colleague, Stuart Airy, to give his presentation on the basics of confined space. So Stuart can be described as a stalwart within 3M. He's been with the company nearly a quarter of a century, and within the last 14 years within the PPE technical team. He is currently the 3M EMEA expert for confined space, and he is also Fit to Fit accredited and is a certified industrial hygienist. So with that, Stuart, the floor is yours, sir.
So yes, hello. Thank you. It's a great pleasure to be with you today. I just have to correct you, David, slightly that I'm studying to be a certified industrial hygienist. I need to cover quite a lot of ground in a short amount of time today. So I'll let you to look at this on screen. There's a few important notes here. And the key one really is there's a lot of information behind safe working in confined space. And listening to me talk for 25 minutes isn't enough to make you a qualified entrant or somebody who is competent in confined space entry. Why are confined spaces dangerous? Well, this is an example from a real world. It's taken from the International Association of Drilling Contractors. It's quite recent, from 2014. A worker entered a water tank, which contained some water and nitrogen mixture, and they were incapacitated. A second worker who observed this entered to rescue his colleague. He became incapacitated. 2 more workers saw what had happened, and they entered to effect a rescue. They too were incapacitated. By which point a supervisor became aware of the issue, the tank was drained, and a further 2 workers entered to make an ad hoc rescue. Of those 4 original entrants, 3 died. These types of incidences are sadly all too common. Looking at some of the statistics we have, and we are limited very much to statistics from the US. Typically, on average, there are 148 deaths due to confined space entries going wrong each year in the USA. Of these, 61% roughly are due to a physical hazard, being engulfed, falling, being struck by, electrocuting, etc. And 34% are due to encountering an atmospheric hazard, an asphyxiation, toxic atmospheres, explosive atmospheres, etc. And going back to that example I showed a moment or two ago, in a slightly older study, multi-facility incidents were reviewed, and 60% of those deaths were down to would-be rescuers entering into a confined space to rescue somebody else. So this is exactly like what we saw before. An initial entrant succumbs to an atmosphere or a hazard, and one or more entrants then go in to try and effect a rescue. They're ill-prepared, and they succumb and die as well. Really very harrowing statistics. So why do confined space incidents occur? Well, you can read all of those potential reasons on screen, and I'm sure there's many more, but it comes down to three main things: a lack of adequate controls, permit access controls, physical controls, lack of atmospheric testing. Second thing is the lack of training, awareness with people who enter confined spaces that they are indeed confined spaces, lack of awareness of the risks, how to enter properly, and the correct procedures which should be in place. And thirdly, the lack of appropriate equipment and PPE. Perhaps that may also be extended to ventilation, inappropriate gas detection, access and rescue equipment. So what are confined spaces? Well, I have to say that the definitions vary around the world. It really depends where you are. So do check out your local or national regulations, and the definitions do vary around the world. But if I could surmise them all together, they have 5 common characteristics. Number one is their size, in that they are large enough and configured in such a way that a person can bodily enter and perform work. The entrance is small, it's limited, or it impedes easy entry and exit. Occupancy. They're not designed for continuous human occupancy. So they are something like a storage tank where normally a person would not go in to work, perhaps daily, to perform a task. There's something where somebody goes in occasionally, and when they do, it may be briefly or for a long period of time to perhaps do quite large remedial works. Rescue. The provision of emergency response services is compromised. By this, I mean, if you, say, had a heart attack, a paramedic could not just simply walk straight in like you would into an office and be able to provide medical assistance. The means of entry is restricted. It's difficult to get the emergency services immediately to somebody. And then, of course, and quite importantly, confined spaces often contain a hazard, a specific named hazard, which can pose a significant risk of illness or injury to those who enter. Here are lots of images of potential confined spaces. Some of these are pretty obvious, like a manhole, a sewer, a tank. Some are perhaps a little less obvious, maybe heating and ventilation, air conditioning controls on a large building, or a reactor vessel in a chemical or pharmaceutical manufacturer. And I'm sure we're going to see a few more examples from Laurent, who will follow me. What type of hazards are we going to find in confined spaces? We're going to find configuration hazards. These are things like risk of falling, entrapment, unprotected edges, fragile surfaces, sharp edges, ground conditions. We're going to encounter things like physical hazards, electrical hazards, mechanical hazards, obstructions, excess temperature or excesses of temperature, very low or very high temperatures, pressurized gases and liquids, free-flowing liquids and solids, restricted movement, all sorts of different things. We may encounter biological hazards, whether they are infectious agents, bodily fluids, biopharma processes, sewage, wastewater, stagnant water, rodents, rodent droppings, insects, snakes, and also things like poisonous plants, molds, and fungi. And perhaps because we are the International Society for Respiratory Protection, we're obviously going to pay a little bit more attention in this webinar to atmospheric and chemical hazards. So obviously we're talking about things like oxygen deficiency, but also oxygen enrichment, explosive atmospheres, asphyxiation, toxic atmospheres, and other chemical exposures, anything from active pharmaceutical ingredients, solvents, and other chemicals, and particularly those chemicals which may be encountered when cleaning or cleaning out a confined space. A fourth hazard, which often isn't mentioned, is psychological and fatigue. Entering a confined space can be stressful. You can suffer from claustrophobia. And of course, with the environmental conditions, the PPE you may be wearing and the work you're undertaking, you can quite easily become fatigued. And that in itself can pose significant hazards to the workers. In the US, it's estimated 1.6 million workers enter over 4.8 million confined spaces each year. But why do they enter? Well, they can be doing a variety of tasks, as you can see: inspecting, repairing, cleaning, rescue, construction. The important thing to also bear in mind is that a variety of different types of people can enter. They could be from the host employer, so the company that owns the site. They could be facilities management, specialist contractors, maybe on a maintenance or repair shutdown, a rescue team, or emergency services. So control of your spaces can be very difficult due to the range of tasks and people who may need to enter them. When we're looking to enter a confined space, we need a safe system of work. This is quite a UK term, so you may understand this with different terminology. It may be very prescriptive depending where you are in the world, but generally these 9 steps form a solid basis, a solid safe system of work for entering a confined space. So first of all, we need to identify all of the potential confined spaces on site, prioritize them, and know what the risks are within them. Do you need to enter the confined space? Could you achieve the task without going in? Is there a different way of achieving the end result? You need to evaluate all of the hazards and identify the risks. Conduct a risk assessment. And that is step number 4. Number 5 is, once you understand what's going on in your confined space, develop a safe system of work, method statements, permits, and a rescue plan for how you will actually get into that space, access it, get in, get out safely. From that, you can identify the equipment and PPE you will need for both entry and rescue. You need to assign roles and responsibilities to all of the entrants, the supervisor, the attendants, and the rescue team. You need to check that all involved are trained and provide training and certification where required. Remember, competency is critical in confined space entries. And then finally, before you can enter, is complete your permit controls and access the confined space. At 3M, we like to break things down a little simpler into the A, B, Cs and the D, F, Gs. And we'll go through each of these in turn. So starting with anchorages A, there are a whole load of different ways of accessing a confined space. It depends whether you're going in horizontally or you're going in vertically. And of course, sometimes you can go horizontal and then vertical. Remember that there are lots of access equipment solutions to get you into confined spaces. It's very rare for you to be able to walk in and out of a confined space simply. And actually maintaining an anchor and a lifeline to any entrant, as I will demonstrate hopefully later, is critical. So you may be familiar with tripods. These are fantastic for simple vertical entries, like those you can see. But often you may encounter a bit of a challenge where a tripod can't be used. There may not be space for the tripod. You may be working up against a wall or a drop, or a tripod can't get around the space. In these types of situations, davits can be fantastic to solve your access problems, whether they be a temporary solution, maybe counterweight with a weights or a vehicle tow bar hitch, or they could be a fixed base. There are lots of different things here and different solutions, and they have lots of novelties and features which can help with access and rescue. You may be going in horizontally, and something like a pole hoist can help you maintain contact and a lifeline to your entrance. And they can also sometimes be used vertically. The B is for body support in our ABCs, and there are some specific harnesses which we would encourage people to use, whether you're entering vertically or horizontally. And in fact, in some countries, it is mandatory that all confined space entrants wear a harness because they can greatly help with rescue by having attachment points for lines, for hooks to be attached to people, for lines to be connected, or for just man-hauling people out if the worst happens. Connecting devices are the C of our ABC. So if you're entering vertically, you may have a ladder, so that's your primary connection, but there's a risk of falling. So something like a retrieval SRL, a self-retracting lifeline, may be an extra component, but you may have to be lowered in if there's no ladder. Therefore, a primary connection is one line on a winch. And again, there's a risk of falling. So a retrieval SRL with a winch, a second winch as a backup, is a good idea. But even if you're going in horizontally into a tank, using a retrieval SRL with something like a pole hoist, it gives you a permanent connection to that entrance. If they succumb, the attendant can instantly engage the winch and haul the entrant out. We'll talk about that a little bit more. D, detection, purging, and ventilation. This is where I'm going to spend a little bit more time. So detection of the atmosphere. We can have a whole range of atmospheric hazards within confined spaces. Low oxygen levels, high oxygen levels, as we've mentioned before. It's always great to know what was in the confined space previously. Is there rusting metal or organic materials? Is there decomposing organic materials, solvents, degreasers? Perhaps you're taking the atmospheric hazard in when you're cleaning, or perhaps you're conducting welding, maintenance, hot work, which could consume oxygen, or the shielding gases or byproduct gases from welding could create an atmospheric hazard. And of course, in these scenarios, you're looking at personal atmospheric gas detectors and maybe area monitors as a backup as well. And why is it important to test for the atmosphere in a confined space? Well, typically the atmosphere doesn't change and it lays stagnant. And then we can get stratification of the gases within the atmosphere. So those lighter than air yellow may go to the top, and those which are heavier than air, a greater specific gravity, may settle to the bottom in different layers. When we're looking to enter a confined space, we need to test around the entrance to make sure we're not leaking something and there's an immediate hazard even outside the confined space. Then we want to maybe crack the lid and test again. And when all is safe, we need to test at different heights down and through the confined space so we truly know what is in our confined space. And only then, and when we are sufficiently happy, we can enter into that confined space. Atmospheric testing before entry and during entries is critical. And here's an example of why it is important for every entrant to have their own personal gas detector. They can enter, it's been deemed safe, but they can move within the confined space and encounter a pocket of lighter than air gas, perhaps by moving upwards into a different space. And a gas detector can help them there. They could go lower and encounter a different atmosphere. Or their action, perhaps cleaning the sludge out of the bottom of a storage tank, could actually create the hazard itself. Different atmospheres can be encountered throughout the space or during the work. On this slide is an example of why multiple gas detectors are fantastic, but they have their limitations. So if we consider a confined space, which is toluene in the UK, the exposure limits, the 8-hour time-weighted average and 15-minute STEL are shown as 50 and 100 parts per million. The LEL, the lower explosive limit of toluene, is 1.1% or 11,000 parts per million. If I was to enter this space and encounter an explosive atmosphere of toluene, my portable multiple gas detector will go into an alarm at 10% of the LEL, which would be 1,100 parts per million. But that alarm state is significantly higher than the TWA or the STEL. So I cannot rely on my gas detector to tell me when I am in a potentially hazardous environment. For that, I may need a completely different type of device, like a photoionization detector. So know what your product can and cannot do. So key things to atmospheric testing. You need a competent person, somebody who will be able to test the atmospheric conditions, have good knowledge and training and experience to perform the tests and interpret the results. Whatever you use needs to be calibrated and appropriate. It must be in good working order, recently bump tested, and appropriate for the hazard, so be able to detect it. This device on screen has LEL, O2, carbon monoxide, and hydrogen sulfide. But if you've got a sulfur dioxide hazard in there, in your confined space, this detector will not be appropriate. You need to keep good records of every test, calibration, and bump test. And you need to continuously monitor the atmosphere. The atmosphere can change due to the work. The temperature in there may increase, and volatiles may be created. So continuous monitoring is required. And it needs to be operated in a safe manner that doesn't risk the safety of the people inside the confined space. Ventilation is also one of the key parts of managing atmospheric hazards. On screen is a general guide to push and pull ventilation. Force ventilation, push, local exhaust ventilation, pull. Whatever you do, you need to match your ventilation system to the air exchange requirements for the space. So if you need to do a certain number of atmospheres exchange and the volume in the space is such, you can work out roughly the capacity of the ventilation system you need. Do account for airflow loss as well with all the twists and turns, diameters and lengths of your piping. And as you can see, different push and pull systems are perhaps more suited to different hazards, emissions, gases, vapors, particulates, and how the contamination may be found. And to give you an idea of some of the challenges or some Incorrect ventilation setups. Here is a forced ventilation, a push. And in this case, in our confined space, the pushed ventilation is being short-circuited. It's not truly clearing out all of the confined space. And in the next example, we have a recirculation problem where air which is being pushed out of the confined space is being pulled straight back into the fan blowing air in. Now, that may be air from the confined space, but it could be from some other source of contamination. You could be taking diesel exhaust emissions from a nearby generator and pushing those into your confined space. So be very careful when designing your ventilation. Here are some simple diagrams of good ventilation systems. So for push, forced ventilation, here we're pushing air all the way down to the bottom. It's pushing out through a different exit access point from the confined space. So this is pushing, and this one is pulling. So local exhaust ventilation, pulling air, good clean air in, pulling it out. And of course, we can do combinations of the two. For when maybe the contaminants are lighter than air, a push-pull is advisable here, where we push the air in and we pull it out in this kind of configuration. And in a different configuration, if we're heavier than air, then maybe we want to push air into the top and pull air out from the bottom. Forced ventilation can be used to dilute the contaminants, and it's more suitable when the contaminants are relatively low toxicity, as we saw, the emission rates of releases are constant, or they're smaller quantities. The contaminants are finely suspended solids or gases and vapors, and the release is widespread. And there's sufficient distance between the worker and the source, and they allow for effective dilution to take place. LEV is better for larger quantities, heavier fumes or solids, where maybe the contamination is more localized and there's insufficient distance between the worker and the source to allow effective dilution. Another atmosphere we may encounter is explosive atmospheres, and it's quite common here to have to purge the atmosphere using a purging gas like nitrogen, argon, or carbon dioxide. Without stating the obvious, we've got an explosive atmosphere, so that is an obvious hazard. But by purging, we can also create oxygen deficiency. We can have residual explosive atmospheres if we haven't purged properly, and we need to exhaust that atmosphere from the confined space somewhere. All things to consider. Of course, ventilation follows purging, and of course, testing the atmosphere before entry. The E of our ABCs is education, critical for all involved to know how to enter and work inside, exit, and potentially rescue others from a confined space. There are many, many courses out there you can go on to become trained and competent. F is full body protection. Remember, there's lots of different challenges in there. Different types of PPE may be required, but one of which often is respiratory protection. Remember that air purifying products are potentially suitable if you're cleaning some relatively low inert or non-toxic particulates. A filtering face piece could be entirely appropriate. But for other scenarios, there are a range of breathing apparatus you can consider, from emergency escape, airline, through to self-contained. And just to give you a flavor of these, escape sets can be compressed air, or they can be chemical oxygen self-rescuers. And these are used to give 10 to 15 minutes of breathable air for an entrant to use to escape from a confined space or any other workplace where an atmospheric hazard could be encountered. They should not be used for working or rescue. If you are having to go into a confined space for an extended period of time and you know there's an atmospheric hazard, then maybe an airline breathing apparatus set is appropriate. So you have a source of air outside, or you're connected by hoses to a pressure demand valve full face mask. Some of these actually have an escape set built in, and if the air is interrupted, the air source outside is interrupted, you have up to a 15-minute cylinder which automatically kicks over, or in some cases has to be manually turned on, which allows you to escape. These types of solutions are great because they're smaller and lighter weight than SCBA, which we'll see in a moment. Because SCBAs, although you've got different cylinder sizes and pressures, they are generally quite large and bulky, and your working time can be limited. To help you make decisions, there are decision trees. I don't have time to go through this today, but we have from 3M, and I'm sure other manufacturers do, the tools to help you decide the most appropriate respiratory protection. And then onto the G, get them out, the rescue hierarchy. Well, the safest rescue, the lowest risk, is a self-rescue. You encounter an atmospheric hazard, your portable gas detector goes off, you don your escape breathing apparatus, and you escape from the confined space yourself. The next in the hierarchy is the non-entry rescue, where an attendant can rescue you without having to enter. You remain attached to a rescue or a safety line, as you can see on this davit, and you can be winched immediately out should a hazard be encountered. The highest risk entry is an entry rescue. Others have to don equipment, enter the space, find the entrant, pull them out, and get out safely themselves. It takes time and it puts others at risk. So if I can say one thing to you is designing the correct equipment and access solution can help significantly minimizing the risks with confined space entry. By designing a good, effective solution, we can minimize the risk of falling. We can provide safe access into a confined space. We can reduce or eliminate the need for others to enter the space, and we can reduce the time it takes for an extraction to take place. We can also provide mechanical advantage to lift people out of a hole or drag them to an exit point. So very briefly now, my final slide, the takeaway messages. Respect confined spaces. They are dangerous and you rarely get a second chance. Be competent, use competent people who are trained and experienced in confined space entry, rescues, and whatever task they are doing. Identify your confined spaces and use permits. Label your confined spaces and put in place appropriate controls. Conduct your risk assessments. Eliminate the risk as much as possible. Follow the rules. Implement a robust, safe system of work. But always plan for rescue. Plan for the worst case and practice it, because unfortunately, the need to rescue confined space entrants is ever present. And when the worst goes wrong, having a competent team and a rescue plan available is your best course of action. So that's me done for now. I'm going to hand over to Laurent.
So, just on that, so thank you very much for that, Stuart. That was fantastic. I'm just looking at the questions so far. The people are, I think, are still thinking of questions. So we'll take those at the end, and we'll move straight on to Laurent, if that is okay with Laurent.
It's perfect.
Fantastic. So just sharing my screen quickly just to move on to my. So our next speaker is Laurent Hervé, who is the Health and Safety Manager and PPE Coordinator with Sanofi. So, Laurent, it's a great pleasure to introduce you, and very much looking forward to your presentation on confined spaces and Sanofi, the constraints. So, over to you.
Guys, thank you so much, first of all, to David, Stewart, and Aldo to propose me to participate at this webinar. It's a very great pleasure, really. And it's always a very difficult situation for me. And I explain why. Because I will just introduce myself. So I worked a long time ago now in Sanofi, in first of all in chemist, in toxicologist, and after in HS different position. So and I had a hobby because I was a fireman in Paris during more 15 years. It's a hobbies. It was a hobbies too, and why it's so quite difficult to discuss about confined space, because long time ago now, but it's always in my DNA, in my mind. I had managed a very fatal situation in confined space, and I need to go to rescue people into the vessel, not just manage the situation, but go directly to the vessel to escape and to try to save the people. So it's for this reason, it's high topic, you know that, and I share what Stewart said in terms of very dangerous situation and so on. You know that, but typically confined space and asphyxia and different kind of this situation, it's very, very dangerous. And it's for this reason I would like, but it's a few times in few moments, how we manage this risk in Sanofi, and we put in three pillars: implication, innovation, and information. And I would like to share with you some innovation in this area, and so how we can manage that in terms of information after that. First of all, it's one pillar of Sanofi management system in terms of HSE. It's a life-saving rules. I'll explain what is it. And after, I would like to share with you a very great innovation in terms of confined space to reduce the risk at the first step. And after, I would like to share with you the win-win partnership between 3M and Sanofi in terms of lot of action, video awareness, and what I say. The name it's 80-20 catalog, and for sure after some Q&A. Yes, you know, Sanofi, it's a very huge pharmaceutical and chemical company. I think it's not necessary to present this company. So as a lot of huge company, we have very complex and sometimes very heavy HSE management system and HSE culture, for sure. It's always in improvement, because I think in this area it's always in improvement, but we have a lot of tools. And just I would like to focus on one. It's life-saving rules. The life-saving rules, it's quite new in Sanofi, because we had a long time ago a lot of SOP, a lot of trainings, session units, and so on. But the life-saving rules, it's just 4 years ago, and we implemented that in the group. And why I would like to share with you this practice, because we introduce directly in 10, say, life-saving rules, the work in confined space, and in the same level work at 8. And typically, this kind of life-saving rules are committed by the ExCom Sanofi, and they are very involved in that, and for sure, all employees must to have in personal training way and roadmap. And for management, exactly the same, and need to reinforce the message for each employee. For example, if you are only in office building, you need to, and we have to, you must to follow these life-saving rules. And typically, and fortunately, if you have in chemical plant and so on, for sure, it's mandatory too. And it's very quite and short message. You will see in few slides after what I mean. It's I will always, I will never. But these rules aim to protect life for sure. Because yes, maybe we can, a lot of companies say, yes, in our company, it's always very high level of safety for sure. And we try to together to improve this HSE aspect and day by day and day to day task. But we can very, in the real life, Stewart said in a few minutes ago, we have always some near miss or some very significant incident and sometimes fatal accident. And so it's for this reason we implement these life-saving rules. It's varied, it's the 8 rules. It's very easy. It's a communicated package, but very easy message and very comprehensive for all employees. Because you know that in the life of this kind of company, sometimes you have chemists, than me, and after you are in HSE management, maybe you have in a chemical plant, in control quality labs, and so on. So you need to have this kind of information because probably in your career, you not directly in front of these topics, but it could be. And so it's for this reason, life-saving rules is very the fundamental message. It's the basis of HSE culture in Sanofi. And after you have some, it's a very light message compared to Stewart present, but it's just the first level of information about this subject. Another things for sure, and the picture you can see on my slide, it's always in Sanofi plants. It's typically this vessel, it's from Val de Reuil with vaccine. It's current topics in vaccine on this picture. You have a lot of SOP and you have a confined space management standard, specific procedure by site and so on. And we have a lot of information about the web interface health and safety for sure. But now, if you agree with that, I would like to show you a technology innovation to avoid in the confined space. In Chattanooga, it's manufacturing a lot of liquid forms. It's plant in US, and they're using a lot of large tanks. And in terms of quality and sometimes cleaning and maintenance, they need to entering in tanks. And so for sure it's confined space and it's very dangerous and painful operation. So the management want to reduce, first of all, 30% and after to go forward to intend zero entrance in confined space. So sometimes one video it's better to understand what I mean and than speak. So it's just 2 minutes, and after we go back to discuss about this subject. Sorry.
At Sanofi Chattanooga, we are using the latest technology and breakthrough innovation to improve process efficiency, product quality, and employee safety. Strategic problem solving, engineering new technologies, And implementing new procedures has allowed us to dramatically reduce confined space entries by over 65%.
It's management's responsibility to support innovation. 500 confined space entries per year. We had to change this.
The use of sophisticated clean-in-place spray nozzles, as well as enhancing our current cleaning procedures, laid the groundwork for this success. Reducing confined space entries creates a safer environment for our employees, improves quality by designing robust cleaning procedures, and increases efficiency by reducing cleaning time. The only required tank entries remaining are quarterly tank inspections. But how can we reduce our confined space entries to zero? Introducing the newest technology at Sanofi Chattanooga, the Flyability Helios drone. This collision-tolerant drone is specifically designed to navigate inside tanks, large pipes, various confined spaces, and inaccessible areas. The Helios has a patented carbon fiber spherical dome for protection. An onboard camera records video in 1080p high definition and transmits a live wireless video feed directly to the pilot's ground control system. This allows the pilot to operate Helios beyond the line of sight. Going into a dark tank with no lighting? No worries, Helios has got you covered. Helios has multiple powerful LED lights for the darkest vessels and is even equipped with thermal imaging to see beyond what the human eye can see.
With the addition of the drone, it's made my job a lot easier by not having to enter the tanks. It's nice working for a company that takes the time and the initiative to take my safety into account.
And with the use of this technology, we can reduce confined space entries to zero, further improving safety, quality, and efficiency. At Sanofi Chattanooga, this is innovation.
So it's just to share this good practice, because we can see just after in few figures, but you know that, and I explained that in pharmaceutical and chemical company, we need to have a very high level of requirement in terms of cleaning procedures, and for sure a lot of maintenance tasks and so on. And in some figures, and the director explains that in the movie, we conducted more than 500 confined space entries in this plant. But it's not in Chattanooga only, but it's a lot in a lot of plants in Sanofi company, and probably it's not only in Sanofi, but a lot of in pharmaceutical, in chemical companies. So we can say yes, it's normal situation. But for sure, around this webinar, there are a lot of HSE manager or operational director and so on, and they know the first step is to reduce the risk, and so sometimes eliminate the hazard. But if it's not possible, it's really important to remove the risk. And so in this case, typically, we would like, it was very ambitious when we decided that it's now 5 years ago we implemented this good practice, and we have a lot of benefits on this practice for sure, because you can just see in terms of inspection times, you can see it's air quality monitoring and so on. And for sure, and typically it's the main topics for us today are HSE risk, and in terms of hypoxia, chemical exposure, and so on. And now, after a few years background, you can see now we have, for exactly the same plant and exactly for the same vessel, tanks, and reactors, we have zero entries into the vessel now. And we are very there we had a very huge commitment of whole team, and it's for us, it's a very great challenge and a great success in terms of confined space. And typically, what is the benefits of this kind of drone? It's not only safety, but efficiency and quality too. And it's for this reason we use it not only for confined space, but to inspection, for example, for pallets, for a lot of things. And I think the last word is for Brian, because Brian are very involved in this project. And when he said, with this addition of the drone, it's made my job a lot easier, but not having to answer the tanks. I think it's very, in the smile, it's very interesting to have this background. Another topics I would like to share with you, and it's another key of not the success point, because I am very carefully with this kind of topics and this kind of sentence. But one key of the progress and continuous improvement, for sure, it's information. And in these topics, in this area, I would like really to thank 3M, because we made a very strong relationship, and so we can measure now a lot of very good way to improve this kind of situation. First of all, because Stewart says that you have a SOP, you have a lot of standards, you have a lot of rules and so on. But after you are the real life. And in this case, we made an HSE vigilance, so it's a learn experience report. And we saw during an inspection, one people into a vessel and no follow the rules. And it's not 10 years ago, and it's not in Asia, or so often it's very easy to say that, but it's not the case. It's very in a huge plant with a very strong and very implemented rules, SOP, and so on. But you know that it's very important to understand this weak signal and why the people do that. Often it's operational requirement. It's often with time and so on. But one of things we identify is because often you have a gap between SOP, right SOP, yes, we have training station and so on, but sometimes we need, a piece of the chain with awareness. And it's for this reason we made a very strong relationship with 3M to develop 2 videos. One of work at 8. It's not the topics today, but it's very important because it's the first step. If you don't know how you can secure during work at 8, it could be and probably difficult to secure during a confined space task and so on. We develop a specific video for confined space with 3M. And so not the whole movie, because it's a quarter, but just a few scenes I would like to show you and to share with you some scenes.
Sphere, personnel, and not designed to be continuously occupied by personnel. There are 2 types of confined spaces: closed confined spaces, easily identifiable, reactors, tanks, and opened confined spaces, more difficult to identify, but which can be just as dangerous: sampling stations, retention tanks. Now, let's review some examples of confined spaces that we may find on our sites. Tanks, silos, boilers, large diameter pipes and ducts, chimneys, manholes, sewerage facilities, pits, wells, underground tanks, cisterns, reactors, mixers, dryers, autoclaves, compactors, grinders. Define ways to ventilate space. Sources of toxic or flammable contamination of the atmosphere can be present in installation or introduced by the entry work itself. To remedy this, the confined space must be ventilated before and continuously for the duration of the entry, by natural ventilation, or necessarily by mechanical ventilation if toxic flammable materials or lack of oxygen. Blowing must be favored. However, extraction may be used in case of works of metalwork, welding, gas bottle must be outside, paint, or resin. People using these detectors are trained in their use and the interpretation of measurements with respect to the thresholds for safe access. Means of communication and alert. Define and test the means. Communication between the attendant and the worker. Alert between the attendant and the rescue team. Communication with the worker must be permanent. Visual contact, voice, talkie or headset, action on the connecting cable. Define and check the fall arrest and rescue equipment of the worker and attendant. Harness, self-retracting lifeline, rescue winch, tripod, davit or pole are to be defined according to the mode of entry. They must be checked at least once a year and before each use. In case of vertical rescue through a narrow access, provide a harness with buckles at the shoulders. Any non-compliant or triggered equipment must be taken out of service and returned to the manufacturer for repair or replacement. Also check that the rescue procedure has been tested with realistic exercises, including the wear of PPE that may complicate the extraction. Your preparation phase is now over. You are ready to start the entry phase. Entering a confined space can be risky. Planning and safely executing the entry ensures you get out in good health.
So, as you can see, it's for us. It's this kind of video and this kind of. It's not training again, but it's a very awareness unit. We increase a lot of our commitment and the good practice on our site. And it's for this reason we translate these movies and the previous one in Travel at 8 at 16 language. And now it's mandatory for all people in our planes. As I mentioned, exactly the same process in life-saving rules. If you have to work in confined space or in work at 8 or just implement or prepare an operation with this kind of task, you have to follow this kind of awareness unit. And typically for us, it was a very great opportunity to improve HSE situation. Another things we made in parallel, it's to work with Arnaud, and thank you so much, Arnaud, and a lot of other people and 3M team. But we define together what we need in our sites, and it's for this reason it's 80% of situation we can find in a specific catalog, and after in 20 cases it's a specific ask and request and so on. We assess together, but a lot of cases we define a very specific equipment, And we define and write a specific technical data sheets, because you know that sometimes we have a catalog, we buy a piece, another piece, and another piece, and another piece, but it works together. Each piece it's okay with the another one. It's very difficult to find the solution, and except if we are very lucky to have a man like a steward of Arnaud not so far of your organization. And it's for this reason we wrote more than 25 this kind of specific technical data sheet, and it's very useful for operational people on our side. And to finish, because it's human history, we organize with 3M and a lot of workshop live, and typically in our plan, in vaccine plan, because we have a lot of tanks and so on, you understand that, but also in another place with a main hall and so on. So thank you so much for your attention, and if you have any questions, for sure, don't hesitate. And again, these topics, it's very, 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 very important, because we can check every day a lot of subcontractors or other very big company. I think, and it's for this reason I would like to share that with you. The level is not what we expected and we attend. Thank you so much for your attention.
Well, thank you for that, Laurent. That was an excellent presentation of kind of end use of confined space in the real world. So no, that was fascinating. I was very intrigued with the use of the ELIO drone. Do you see that as the way forwards with confined space, especially in kind of the bulk areas that Sanofi look at? Is there plans to include gas detection in that area, or is it just to take the human out of it altogether?
Not for the moment. It's just only we sample the air and do a measurement before, but after we go with the drone after. But we have a project to have all in one. But for the moment, it's difficult with the quality department, because it's always a balance between quality and safety. But it's I think a great step for the moment, but we work to improve the situation. But now we have drone in almost all chemical and pharmaceutical plant to do that and decrease radically the entries or into the confined space.
Okay, brilliant. No, that's fantastic to see. And then a question for Stuart: as that kind of technology matures, and I'm very conscious in mind of your excellent overview of ventilation. So when we're talking about more dense than air and less dense than air environments with ventilation, where you could have potentially a dynamic confined space, if that makes sense, from a respiratory protection perspective, I assume that makes it more important to real-time gas monitor all the time that the person is within that environment.
Yeah, absolutely. You've got to monitor and test before you enter. And as you saw through the various through the depth of the confined space due to the risk of stratification, it's critical. But we got to remember that we can move in different confined spaces. We can go into a reactor vessel or a tank like what we saw at Sanofi, and there's not very far you can go. But in some of the examples, Laurent was also showing there were very large spaces, and you can detach and walk many meters, if not dozens, tens, maybe hundreds of meters away from the entry point, and you can encounter a very different atmosphere when you do that. And you can go up and encounter different atmospheres or go down. And as we were saying as well, whatever you do can actually create the atmosphere as well. So you could be cleaning, you could be welding. And, tragically as well, there's examples of something as simple as the sun coming out on a tank containing some organic materials, heats up the tank volatiles start coming off the sludge in the bottom, and the atmosphere can change dramatically with only a few changes, a few degrees of temperature change due to the sun. So they're so dynamic, and because the atmospheres are so small in them, the limited atmosphere in there, so a small change has a big effect on a confined space. If you can ventilate, if you can monitor, you can minimize the risks, and you know when you've encountered something which is hazardous.
That's fantastic. Thank you, Stuart. Very detailed answer. Just looking at the question, the chat and the question and answers, I think you've stunned everybody into silence with two wonderful presentations. So I'm just going to share my screen again to move on to the final part of the webinar, which is to just close it out, to thank both of you for two excellent presentations. Your presentations will go out to the audience, so I'm sure there will be follow-up questions. In terms of next steps, our final webinar for the European section for this year will be on December the 9th, and that's around radiological hazards. We've got 3 keynote speakers, and that is being run in collaboration with the Society for Radiological Protection. So that's on December the 9th. And again, COVID restrictions hopefully will lift soon, so we'll get to have face-to-face meetings with the section. But in the meantime, we are planning a 2022 webinar program just like this year. So if anybody in the audience has ideas or themes or actually wants to volunteer for a presentation, please contact myself or the secretary at the ISRP, Mike Williams, and we're more than happy to take any suggestions and ideas on board. So with that concludes today's webinar. And the last thing, I would like to thank everybody for attending. I hope you've enjoyed the webinar. And a very big thank you to Stuart Airy from 3M and Laurent Hervé from Sanofi, who I think gave a fabulous set of presentations. And just to thank you with a virtual round of applause. So thank you very much, gentlemen. And wish you all a pleasant rest of your morning, evening, or the rest of your day. Thank you very much.